Hello, this is Jack Jackson. In our last video, we talked about how we can look at a revenue and cost function and how they relate to profit function. In this video, we're going to look at an actual application, real-world application, and it has something to do with some of these concepts. So here's our problem, or our scenario. A 400-room hotel is filled when the room rate is $58 a day. And they have found that for every time they increase the rate of the room by $1, 5 fewer rooms are rented. So first question is, write the daily revenue function R as a function of the daily rate of renting a room, lowercase r. So capital R is revenue, lowercase is rent. In general, in mathematics, a lowercase letter and an uppercase letter are two different variables. So be sure when you're writing mathematics that you're careful to use the right case. And then sometimes we even use like maybe a Greek version, like a row or something. That's even another variable. Okay, anyway, see if you can come up with a formula for this. So get big R in terms of little r. And I'm going to ask you to kind of pause the video each time we ask one of these questions and see if you can answer it yourself. So pause the video now. Well, hopefully you came up with this relationship. If n is the number of rooms rented, that's kind of a useful thing to know. So the number of rooms rented is 400 minus 5 times r minus 58. So this is a point slope version of a line. Since increasing $1 in rate decreases $5 rooms rented, that is a linear relationship between R, big R, and little r, and it's a linear relationship between the number of rooms rented. I'm sorry, it's a linear relationship not between R and R, but between the number of rooms rented N and R. So N and R is a linear relationship. The slope is -5, so it's delta N over delta R. So it's -5 over positive 1 is -5. And then we have R minus the point that we know is 58 for little r and 400 for N. So this is a point slope form of that line. If we work this out this way by distributing combining like terms, this is the slope y-intercept form of that same line. So I just distributed the -5 and combined like terms there. Okay, now we know that in general the revenue function is basically the number of items, the quantity, times the cost per item, the unit cost. The unit cost for the room is we're calling the rental rate, R, and the number of rooms is N. So there's a nice little formula, very easy formula for R, but it's not really in terms of just R, it's in terms of N and R. But since we have N in terms of little r, we can substitute that in, and now we have big R as a function of little r. There it is factored, or if we distribute, we get this version here, and we see we have a quadratic relationship between little r and capital R. What's the marginal revenue function? Okay, as always, every time I ask one of these, press pause and then come back. Press pause, work it out. Okay, so you've worked this out, hopefully. You know the marginal means derivative, right? So we're just taking the derivative of that. That's a quadratic, so it's pretty easy to do. It's just 690 minus, and then 2 times -5 is 10. It goes down to 1. So it's 690 minus 10R. So what room rate maximizes the daily revenue? Well, we just want to take the derivative. Well, press pause, you do it. Okay? Now what you should do is take that derivative, set it equal to 0, and solve. So we want to, say, add 10R to both sides, divide both sides by 10. R is 69. And so a daily rate of $69 per room will maximize the daily revenue. The question now is, at that point, how many rooms are rented, and what is the daily revenue, that maximum revenue? Okay, so the number of rooms is 690 minus 5 times 69, which is 345 rooms, leaving 55 vacant. And 690 times 69 is minus the 5 times 69 square, gives us the total daily revenue of $23,805. So if they want to maximize their income, then they will set the rate at, what was it, $69 a day. Now they're going to end up with some vacant rooms, but they will maximize their revenue at that point. Okay, here's another one, a very similar kind of problem. Let's go ahead and work this one out as well. Okay, a 250-room hotel is filled when the room rate is $50 per day. For each $2 increase in the rate, 7 fewer rooms are rented. But this one we're going to also figure in cost. It costs the hotel $15 per day for each room rented in upkeep. In addition, the hotel has fixed costs, including such things as their mortgage payment, the pool upkeep, and so forth, which are independent of the number of rooms rented. And these costs, let's say they're $5,000 a day. Find the room rate that maximizes not revenue this time, but daily profit. What's the maximum daily profit, and how many rooms will be vacant? So let's use these letters. Again, we'll use little r for the rent, which is in room per day. N is the number of rooms rented. Capital R is the daily revenue. Capital C is the daily cost. And capital P is the daily profit. And see if you can figure out what this one is. So we want to know what rate do we need to charge to maximize the profit. We want to know how many rooms will be rented and how many will be vacant. And we want to know maybe what the revenue and cost are. Okay, so I'm going to ask you to work this one out yourself. Work all of it out to the end, and then when you're finished, come back and check your results. Press pause now. Okay, so we're back, and here I have things rented out, worked out. So we have this statement here: for each $2 increase in the rate, 7 fewer rooms are rented. Now, by the way, this is probably not realistic that it's a completely linear relationship between this, but it is realistic that as you increase the rate, fewer people will want to rent the rooms. So, if it turns out that it's exactly 7 fewer rooms every time you raise the rent $2, that's a linear relationship between the number of rooms and the room rate. So here I did it, I did a slightly different way than the last one. I didn't use the point slope formula. I just started with the slope-intercept formula. N equals M, it's just y equals mx plus b, basically. But y is n, x is r, b is the y-intercept there. And the slope, m, is -7/2. That's delta y over delta x, or in this case, delta n over delta r. So it's 7 fewer rooms when you increase by 2. And so we plug that in. -7/2 is -3.5. Now, how do we find b? Well, one way we can find b is put in the point we know that when it's $50 per day, we rent all 250 rooms. So 250 here goes for n when we put in 50 here. And if you'll solve that for b, multiply this out, add the opposite to both sides, you get b is 425. And we work this out. Okay, now let's take that, and that's our formula for n in terms of little r. Capital R, the revenue, is the room rate times the number of rooms. So substitute in this expression here for the number of rooms in place of this n right here, and we get that right here, distribute, and now we have this nice little quadratic expression for capital R in terms of little r. Now, how about cost? Well, cost, it's $15 per each room. So it's 15 times n, plus you have the fixed cost of $5,000. So there's your cost function. But again, that's a cost as a function of n. We would rather have everything in terms of the rental rate, R. So once again, we take this expression for N and replace it in place of N there, which is what we have right here. Okay, so that's our whole formula. Distribute, combine like terms, we get this nice little linear function as C as a function of R. Now we have everything in terms of little r, the rental rate. There's the revenue right there in terms of little r, and there's the cost right there. So now we can find the profit, which is revenue minus cost. So there's revenue minus and cost right there. Distribute the negative, combine like terms, and we get this nice little quadratic expression for the profit as a function of the rental rate. To maximize the profit, we take its derivatives. That's not too hard to do. 2 times negative 3.5 is negative 7, goes down to the first power. The linear part's just the coefficient, and the derivative of the constant part's 0. So there's our marginal profit function, or our derivative of the profit. Set that equal to 0, which we do right here, and then say add 7r and divide by 7, and we get there is the rental rate. And so that's the part we want is $68.21 per night. We'll maximize our revenue, or maximize our profit, not necessarily our revenue. Maximize our profit. Put that back into the profit formula, which was back here. Put the 68.21 in place of all those r's. That gives you this expression here, which simplifies to $4,911.16. The number of rooms that will be rented is you put that number in place of R in the number of rooms rented here, and that works out to be 186 rooms will be rented, which means 64 will be vacant. So if they want to maximize the profit and they have to charge everybody the same amount, then it's going to be $68.21 per room each day, and it's going to result in $4,900 per day profit, and it will leave 64 rooms vacant and 186 rooms rented. This sort of problem is very typical thing that you have to think about when you're setting your prices. In general, if you raise your prices, you're going to get fewer customers, but you're going to get more per customer. If it's too high, then you lose enough customers that your profit's going to go down. Whereas if you set it too low, you may get lots of customers, but it's not going to make up enough to be your best situation. So there's some place in there, there's a sweet spot where you charge the optimal amount, and that will maximize your profit. This is a typical kind of thing that, whether you're running a hotel or whatever you might be doing, that you might be interested in finding out. So the trick here, of course, is to be able to find out these relationships like this one here. Knowing an initial condition like that's not going to be too hard, but being able to keep up with these types of things right here will allow you to make these formulas, and from there you can use a little calculus to find that maximum sweet spot where you make the most profit.